Hello and welcome to our video solutions for Quiz 4. This is from my fall 2021 Math 106, which is Integral Calculus and Differential Equations class. And this is the first video solution. In this problem, we're just doing a little integration by parts as part of a definite integral. So obviously we're using the second fundamental theorem of calculus in this problem. We're going to start by identifying the integrand as, we'll call this f prime of t. So let's just make a little notation over here. F prime of t is sine of 2t times e to the negative 3t. And we want to find an antiderivative. All right, so if we can find an antiderivative, call it f. Then we know by the second fundamental theorem of calculus that this is going to be f of pi over 2 minus f of 0. All right, and the problem itself tells us what technique we should be using, right, which is going to be integration by parts. It says we prefer the tabular method, but if you want to use the long form, of course, that's okay. It's just longer. So let's get to using the tabular method. So for the tabular method, I'm going to pick one of these functions to differentiate and one to integrate. And many of you, of course, know the LIATE rule, which is telling you, oh, you should be doing the trig as your u and then the exponential as your dv. It doesn't really matter. It turns out when you have a sign and this exponential, like you could do it either way and you'll get an answer. But I'll stick with I guess the traditional approach. Just because it's in the order it's given. So I'm going to differentiate the sine function, and that will give me cosine of 2t, but then, remember, chain rule, got to multiply by the derivative of 2t, so I get an extra 2. Then I'm going to anti-differentiate this exponential, and that's going to, I just copy the exponential, but then if I took the derivative, the chain rule would give me an extra negative 3 factor. I don't want that. So I have to divide by a negative 3. So we'll multiply by negative 1/3. Okay, now if I stopped here and multiplied across, I would have a different integration problem, right? Okay, some constant times a cosine times an exponential, which is no better than what I started with, right? A sine times an exponential. So I'm going to differentiate again and integrate again and hope I get something better. So when I differentiate again, okay, the derivative of cosine is going to be a negative sine of 2t. Again, the chain rule is in play. I have to multiply by another factor of 2, so I'll get a negative 4 factor. All right, and when I anti-differentiate, well, the same thing's going to happen. I can copy the exponential. I'll have to again divide by negative 3, so this will give me 1/9. Now at this point, I notice multiplying across, okay, I get some constant, but then I have the exact same function I started with, the sine function times an exponential. And this suggests I should be in the I trick situation. I should just really almost stop here. All right, now what I'm going to do is go into the box. I'm going to move all the constants over to the left, so I have negative 4/9, and I'll just move this sine of 2t over to the right. And if we call well, we already have a name here for the integral. It's going to be f. So that's what I'm looking for. If I integrate this, I get f, right? That's what I'm looking for. So there's f. And if I differentiate negative 4/9, I get 0. Okay. And once I get a 0 on the left, of course, that means I'm done. I'm going to draw my lines. Now remember, I can always have lines outside the box, but no lines inside the box. All right, so nothing inside, because inside the box, all we're doing is moving things around, right? We're just changing the u and dv for the next step. And then we have plus, minus, plus. And so in total, our f, which is what we were looking for, right, or f of t, right? I could write f of t if I wanted, okay, is going to be, let's see, the first two are going to have an exponential. So let me pull the exponential out. And what's left over? I have a negative 1/3 sine of 2t. Then I have negative 2/9 cosine of 2t. And then the last one, well, this doesn't have the exponential, so I'll close this parenthesis. I get minus 4/9 f of t. All right, now the goal, of course, is to solve for f of t. So I'm going to have to add 4/9 f of t to both sides. All right, so I'm going to add 4/9 f of t. And let's see, when I do that, I'm going to get, I guess, 13/9 f of t. Okay, and that's going to equal all of this stuff, which I'm going to copy, but I'll save myself a little time here. Okay, by just doing a little copy and paste. Okay, and then if I want actually f of t, I'll multiply now by 9/13 on both sides. So I get f of t is, and you know what? Let's pull this minus out. That feels pretty good to pull the minus out. 9/13 e to the negative 3t times, we have a third sine of 2t plus 2/9 cosine of 2t. All right, cool. So we have found our f of t. All right, that's our antiderivative. And so now, let's just copy that up so we can see it still. Okay, I'm just going to put this at the bottom so we remember what it was. All right, just move that over a little bit. Beautiful. So by the second fundamental theorem of calculus, this definite integral is going to equal the value of this function f that we found down here. Parenthesis got lost, at pi over 2, and then we'll subtract the value at 0. So let's see, first, at pi over 2, looks like we get negative 9/13, that's going to be here, times e to the negative 3 pi over 2. Okay, well, there's a negative 3 pi over 2 in an exponential, that feels pretty good, times, now let's see, at pi over 2, what happens? Well, each of these has a 2t, so let's just note, 2 times pi over 2 is equal to pi. All right, sine of pi is 0, so that term will go away. Cosine of pi is negative 1, so I end up here with a negative 2/9. Okay, so this bit is f of pi over 2. Okay, now we need to subtract what happens at 0. So at 0, we go again, we have negative 9/13. And then e to the, well, that now becomes the 0 power. So that's just a 1. Times, okay, well, 2 times 0 is 0. So we have sine of 0, which is still 0. And then we have cosine of 0, which is 1, times 2/9. Okay, and so this piece is our f of 0. All right, we do a little bit of simplification. We notice, okay, a negative and a negative, that's a positive. There's a 9 in the numerator and a 9 in the denominator. Those will cancel, and I'm just left with a 2/13 times the exponential of negative 3 pi over 2. Then over here, let's see, 9 and 9 cancel again, so we get negative 2/13, but we're subtracting, so it becomes plus 2/13. And that's the answer, right? It matches, hey, exactly what the problem told us it was. If this had been something different, okay, maybe we would worry. We made a little mistake. We go back and check, right? Maybe there was a sign error somewhere, right? Easy to do. All right, so there's two major components to this problem, right? We have the fundamental theorem of calculus, right, which is telling us in order to compute a definite integral, we need to find an antiderivative of the integrand, and then find the net change at the endpoints, right, given by the bounds of integration. The second thing is, in order to find that antiderivative, we want to use integration by parts, okay? Oh, I guess I never copied it in here, but we see it down below. Okay, so we wanted to use integration by parts. We can use the tabular method, and as is common when you have a trig function and an exponential, you end up using the so-called I trick, right, where you end up solving, okay, an equation for f, right? You just basically do integration by parts till you get f again.